Alright, another way to represent data, and this is probably something you haven't seen before, is using something called matrices. So matrices is plural, and then singular is a matrix. So this is just another way of taking numerical data and representing it in a way that other people can make sense of it. Now, of course, for other people to make sense of it, they have to be on the same page as you about what the numbers mean based on how you've written them. And so just like plotting points or making equations or functions or graphs, this is something you want to be familiar with. That way, if other people are talking about it, you know what they're talking about, and they hopefully will learn it so that when you talk about it, they know what you're talking about. So a matrix is a grid-like way to store numbers. So if you have a lot of different numbers, you can store them in this kind of grid structure. And every matrix, if it's going to be a grid, has to have a certain number of rows and a certain number of columns. So for example, you talk about matrices based on their size, which is the number of rows and columns. So you might say, I had a 2 by 3 matrix. That means it's, or sorry, a 3 by 2 matrix would be 3 rows by 2 columns. So the rows comes first, columns come second. So a 3 by 2 matrix would look something like this. Okay, so it's going to be 3 rows and 2 columns. So you can put in some numbers. I'll just put in random numbers. 1, 2, 3, 4, 5, 6. So that right there is a properly written 3 by 2 matrix. So you can see it has 3 rows, 1, 2, and 3, and it has 2 columns, 1 and 2. And you just write the numbers with space between them. So it's kind of a very abstract way of writing it, and it sometimes is annoying. If you write really small and you cram these things together, it's hard to see if this is 2 different rows or if it's 1 row and the numbers are just 12, 34, and 56. So when you're writing a matrix, you want to be very careful to show it in clear handwriting so you can see whether it's 2 rows or 1 row, etc., etc. Sometimes when I'm doing my matrices, even though it's not proper notation, I actually like to go maybe very lightly or in a different color or with dotted lines. I like to add in some grid lines like this that helps me separate and see exactly which numbers are in each location, first row, first column. So this right here is first row, first column. This is second row, first column, third row, first column, first row, second column, second row, second column, and third row, second column. So you can identify each of the different pieces in your matrix by which row it's in and which column it's in. Okay, so what are these used for? First, we figure out what they are. Now we talk about how do we use them. So to add or subtract, the matrices have to be the exact same size, and you're just going to add or subtract the corresponding parts. So let's take a look at 2 by 3 plus a 2 by 3. So your first matrix is going to be a 2 by 3, and then we're going to add another 2 by 3. So let's put some random numbers in here. 2, negative 5, 0, 1, 6, and 3. That could be our first matrix, 2 rows, 3 columns. And our second one might be something else that's random, 7, 9, 2, 12, negative 5, and negative 30. Okay, so in order to add or subtract 2 matrices, you kind of line them up as if they were on top of each other, and you add or subtract the corresponding parts. So our corresponding parts are going to be first row, first column of this matrice with first row, first column of this matrice. So they kind of line up together, and then you just do basic adding and subtracting on these 2 numbers. So 2 plus 7, and our answer is also going to be the same size. So 2 plus 7 is 9. Then you move over to the next one, here and here. Negative 5 plus 2 is negative 3. Move over to this top right corner and this top right corner, and you get 0 plus 12, that's going to be 12. And you keep going just like this, so 1 plus 9, and then middle bottom, 6 plus a negative 5 is going to be 1, and 3 plus a negative 30 will be negative 27. So you can see that it's important that these 2 matrices have the exact same size, because if they didn't, you would have something in the first matrice and you were trying to add or subtract, but there's nothing in the second matrice. There is no position corresponding to that. So when you're adding and subtracting, you need them to be the exact same size. And you may still be wondering, like, okay, that's great, I know how to add or subtract them and I know how to write them down, but what do they possibly represent? What do they actually mean? And the only thing I can tell you right now, maybe this is a better question to ask in class and I can explain it, but they're a way to store data about multiple things. So for example, say you're a pizza parlor, you might have a matrix representing all the different sizes of pizza and all the different prices. So each row might represent different sizes. So the first row could be small, then medium, then large. and then the columns might be, a meat pizza or a 2-topping pizza or a special pizza, and then all the numbers that you put inside that grid structure, that matrix, could be the different prices based on what it is. So if you want a large, specialty pizza, you go to the 3rd row and the 2nd column, and then whatever number is in that spot of the matrix will represent that price. So they're kind of an abstract way of storing data about situations. And I can explain more, give more examples in class if you want to ask. But basically for now, it's important that you recognize what is a matrix and that you're able to mathematically add or subtract them, and then we'll move on from there. All right, good luck.